You SSH to a jump box, then SSH from there to a database host. It works because agent forwarding is on. Now picture that jump box gets compromised, or a privileged admin on it is not someone you intended to trust with your identity. They do not need your private key file. While your session is connected, they can use your forwarded agent socket to authenticate onward as you. That is the failure mode. Agent forwarding is convenient, but it turns the hotbox into a place that can spend your credentials in real time. Agent forwarding exists for a reasonable reason. You keep your private key on your workstation, load it into ssh-agent, and avoid copying private keys onto servers. In the old workflow, you SSH to a Bastion, then from that shell run SSH again to reach an internal machine. Without forwarding, the Bastion has no credential to present. With forwarding, the second SSH command can ask your local agent to sign. OpenSSH understands the risk, so the default is ForwardAgent no. If forwarding is active everywhere in your config, someone chose convenience over a safer design, often with a broad host star block. Mechanically, this is not magic. Your remote login gets an environment variable named ssh auth sa. It points to a Unix domain socket on the remote host, usually under a temporary SSH directory. When a process on that remote host connects to the socket and asks the agent to sign an authentication challenge, SSHD relays that request back through your SSH connection to your local client, and then to your local agent. The private key normally stays on your machine, but that distinction is small comfort. The remote side can still cause signatures to happen. Root on the remote host can inspect processes, reach protected files and sockets, and impersonate enough of your session to use that socket while it exists. The first line is the dangerous convenience form. SSH-A enables agent forwarding for that connection. Know it, but do not make it your normal path. The second line is the safer replacement. SSH-J connects to app.internal through jump.example.com, while your local SSH client still authenticates to the final host. The config block makes that permanent for app.internal using ProxyJump. ForwardAgent no is shown explicitly, even though it is the OpenSSH default, because explicit denial prevents surprises from broader config. The last line reloads a key into your agent with confirm per use. Every signature should prompt you, assuming your AskPass setup supports confirmation. Here is the common pattern. You administer app.internal, which is reachable only from jump.example.com. The old method is to run ssh-a jump.example.com, land on the Bastion, then run ssh app.internal from that shell. The Bastion now holds access to your forwarded agent socket. The better method is to run ssh-j jump.example.com app.internal from your laptop, or put the ProxyJump stanza in your user SSH config. The Bastion is now transport, not a credential consumer. It sees an encrypted SSH channel passing through, but it does not get your agent socket for authenticating onward. The worst mistake is putting ForwardAgent yes under host star. That means every random server you SSH into gets a live path to your agent. Another mistake is leaving forwarded sessions open in tmux or overnight and forgetting the socket exists. Do not tell yourself the key was not copied, so I am safe. The operational risk is use, not theft. Also remember that confirm per use is only useful if the prompt appears where you can actually approve or deny it. Test it. OpenSSH also has destination-constrained agent keys with SSH-H in newer releases, but version and path rules matter, so treat that as an extra control, not a replacement for avoiding forwarding. This topic sits right between key management and network access design. Agent forwarding feels like a key feature, but the real lesson is trust boundaries. A Bastion should help you reach protected systems. It should not automatically become trusted to act as you. ProxyJump belongs in the same mental bucket as clean host blocks, limited users, logging, and server-side restrictions. As this practitioner tier builds up, we are moving away from one-off SSH commands and toward repeatable administration patterns. The pattern here is simple. Keep authentication decisions on the client whenever you can, and make forwarding an exception you can explain. On your own lab machine or VM, do a quick comparison. First, make sure you have an agent running and a key loaded. Connect to a host you control with agent forwarding enabled. Then print SSH auth sock in that remote shell. You should see a socket path. Disconnect, Connect normally or with agent forwarding disabled, and print it again. It should be empty or unrelated to your local agent. If you have 2 lab hosts, make one the jump, and connect to the second with ProxyJump. The goal is not to build a complex lab. The goal is to see that forwarding creates a remote socket, while ProxyJump removes the reason for it. 3 beats to keep. First, ForwardAgent does not usually copy your private key, but it exposes a socket that can make your agent sign while the session lives. Remote root on a hotbox can use that. Second, the safer modern pattern is ProxyJump, because your local client authenticates to the final host through the jump host without handing the jump host your agent. Third, if you must forward, keep it narrow and use confirm per use controls like ssh-add-c, tested in your environment. New SSH episode daily on this channel, plus the daily ranked CVE brief for defenders.